Okay, hello. I'm Yannay, and in this talk, welcome to my talk, Modern Adventures with Legacy Protocols. In this talk, I'm gonna discuss a research I was doing since 2018, more or less, in which I got the capability, and I'll tell you how to do IP spoofing by yourself, which is quite cool. And for this research, I received the Pony Award in Les Blackett for the most underhyped research. And if you want to know what the hype was not about, just stick with me. So let's get this out of the way. I'm Yannay. I'm a security researcher. I'm doing some low-level embedded stuff, browsers, whatever. And this talk is not affiliated with my employer because my employer has nothing to do with it. I did it in my spare time. Okay. How this talk is gonna be. We'll have some background motivation. What is IP spoofing, why you want to do IP spoofing. And then I'll talk about my research, how I done it, the struggles, what worked, what didn't work. And then there will be a short demo that I hope will work. And then I'll discuss the findings. I'll talk to you a bit about the disclosure procedure. So if you're interested in how disclosure works and what to expect, that might interest you. Spoiler, it wasn't fun. And last, I'll talk a bit about future research that can be done using this research. So, without further ado, what is IP? A quick reminder, IP is how we send packets on the internet, and every packet that goes on the internet has 2 bits of information in it, a source and a destination, and the destination is what we use to basically send the packet to wherever we want it to be. So this is the destination address. And the source address, well, it should be the address from which the packet originates. So when we're sending a packet, we should write our own address. But, of course, the flaw is that basically nobody is verifying that the source IP is the right IP. So if my address is 1234, I can put 5555 there. And the problem that can arise from this is that if a service receives a packet and the source address is like from the real Slim Shady, and the real Slim Shady is asking you to do something, and you believe it's the real Slim Shady, because it has the address of the real Slim Shady, then you will do whatever Slim Shady is asking from you to do, and this is kind of authentication bypass. Another problem that can occur is that maybe you're an unsuspecting server on the internet, and all of a sudden, someone is sending you a packet with a spoofed source address, and you're receiving this packet and you say, hey, that's not for me, I'm not doing whatever you're asking, and you're sending a reply. And you're replying to the source address. Now, if the source address is spoofed to be somebody else, you'll just send the packet to some other unsuspecting server. And if too many servers are doing this at once, basically, you can execute a denial of service attack. Okay, so these are the 2 things that IP spoofing can lead to, and let's see some examples for that. So these are research I was doing in the last 10 years or so. So this one is the more recent one. I researched this OBD tracker. So this is a device that's used by fleet managers to know where their cars are at any given moment of time, because they have many cars, they have many drivers. They want to know where the cars are and some basic information about the car. So they can buy this device, put it in every car they have, and now they can have the location, the GPS location of every car they have. The problem with this embedded device is that, one of the problems actually, is that it's used to receive commands from a pre-configured management server. And the only authentication they have for that the commands come from the server was the IP address of the pre-configured management server. So, and it was done, the commands were sent over UDP, of course, because why not? And there was no authentication, and you can send any command. The command I choose to send is firmware upgrade, of course. So I could do IP spoofing and send a firmware upgrade command and upgrade the firmware of this device. And this let me send any message I want to the CAN network in the car. This network is the network with which you're sending commands to every computer of the car. So the engine, the lights, the windshields, whatever. So basically you can just completely take over the car. These vulnerabilities were disclosed a few years ago, so they're fine. The second motivation is a bit more complicated, but I was part of a red team. We're just, trying to do some pen testing on this web server, and my teammates got a local file read, right? Something called LFI. And the title is quite small, I don't know why, but okay. And we could read the code from this server, and the server was doing something a bit weird. So I'm very sorry there is a PHP code in here. This is the last time you'll see PHP code in this talk. But for you who have the luck not to know PHP, what the server was doing, it was making an HTTP request to some third-party server, let's say foo XYZ, and the server was replying with a JSON. And the way this web server thought would be smart to parse the reply was to write the reply to a file and then evaluate it as PHP. And this is a very bad decision. Yeah, I can see on your faces. You know it's a bad decision. Because now, now if an attacker like myself can control the JSON, basically I can execute any PHP code that I want. Right, cool. So basically, we read the code, we see that the target was fetching and evaluating the JSON, and then we can use the local file read again to read the proc file system, which gave us the addresses of the connection between the two servers, right? If you don't know about TCP injection, it's a bit hard to explain, but I'll do it in a second. I want to send data inside the TCP connection. I have to know 5 things. The source address, the destination address, the source port and the destination port of the connection, and something called a sequence number. And if I know all these things, I can send any data I want if I have IP spoofing capabilities. And to get all these things, I can read the proc file system. So this gives me the addresses and the ports. And to infer the sequence number, we used a very old bug in the Linux kernel that didn't have a CVE. It was fixed in 2012, but the fix was not very widely deployed at the time because it didn't have a CVE. It's by this really, really cool researcher that I don't know how to pronounce his name, but he's very cool, and check out his other work. I'm sorry. And we used all that, and we used our IP spoofing capability. We did TCP injection. We injected a PHP code instead of the JSON, and we basically got an RCE on the target. So these are 2 examples in which IP spoofing can be very, very helpful, and were helpful to me. So I'm not that smart. I did not invent IP spoofing or TCP injection. That's as old as IP, I think. And for this reason, about 20 years ago or so, the Internet Engineering Task Force came with this guideline that said that internet service providers should filter, should put firewall rules that will prevent this attack. So this is these are quotes from the BCP 38 from this guideline, and they want to defeat IP source address spoofing, and they're telling the internet service providers, please block IP packets entering the internet which have source IP address, which are forged IP addresses that were not assigned to the device which is sending them. Because you're the ISP, you're the one assigning the IP addresses to everyone connected by you. So you know what is the correct IP address, and if you see a device that's sending a packet with an IP address which is not the one that you assigned, please drop them. And basically everyone implemented this guideline. I'm from Israel, and Israel, all the ISP implemented it. I couldn't find an ISP that does not do IP ingress filtering. All the cloud providers implemented it. Google, AWS, I didn't check Azure, but you can. I believe they do it. And this is a bit annoying, and you're probably asking yourself, well, but you just said you did IP spoofing in the last 10 years. And the answer is complicated. So in the first one, I was lying. I didn't actually do IP spoofing. I reported a vulnerability that could arise if IP spoofing is possible. And the second one, well, so, oh, yeah, there is this. I forgot this, that you shouldn't think about mitigations too highly. But let's go on. So in the second one, the servers that I injected the JSON or the PHP code didn't talk in IPv4. They were talking in IPv6, which is the latter version of the Internet Protocol. And the thing now is that I did not have an IPv6 connection. I only had IPv4 connection. So what I do, I went on Google and wrote, how can I send IPv6 packets if I only have IPv4 connection? And the internet was very helpful, and it gave me this IPv6 over IPv4 tunneling server that after a short registration would let me send any IPv6 packet that I wanted, including the one that I wanted to spoof, right? Because I was spoofing IP packets. And in retrospect, I realized that there was no filtering. So this IPv6 tunneling broker did not filter my packets. And that led me to the very nice conclusion. By the way, if you like these things, I have another Twitter account in which we used to post this kind of inspirational quotes for exploiters. So I'll put the link in the end. But this led me to realize that sometimes it's not about what you actually trying to do, but sometimes it's about the way, right? Sometimes it's the things you collect along the way. And maybe there is a similar protocol, or maybe there are more brokers on the internet, like the one that was doing this IPv6 brokering, that would actually let me do IPv4 brokering without filtering. So I was checking out if there is an IPv4 over IPv4, and lo and behold, there is an IPv4 over IPv4 protocol. It's actually one of the oldest protocols over AP that existed. You can check out all the existing protocols in /etc/protocols on your Linux machine if you have one. Maybe not all of them, but most of them. And this IPv4 over IPv4 was the first ever tunneling protocol. It was like a very, very, very primitive VPN. And it has no authentication. It's really impossible to set up because, well, I failed to set it up when I wanted to do some testing. And this should be extinct because today we have much better alternatives. We have, WireGuard for VPNs, right? We don't need IPv4 or over IPv4. But I decided to research this. So how do you start such a research? Well, first thing you do is how do you send a simple IP packet, right? So this is a Scapy package for Python that let you send some IP packets very easily. So if you see in this first example, I just defined an IP packet. I say the destination is where I want to send my packet. 999 is the address I want to send the packet to. Then I stack some data over it using the / like the protocol stacking operator, and then I send it. And if I want to do IP spoofing, right? So let's say 1234 is a server, is like a broker that would do IP over IP for me. Then I can send a packet, and you see the first packet is the same, but this time I'm writing that the source address is the broker's address. And the second packet is the one carrying the former packet. And this one would be sent to the broker, and the destination address is the IP service. And just sending these two one on top of the other would do the trick. I'll show you this soon in the demo. But this would fail, right? Because now I am filtered by my ISP, by my cloud provider, by someone. But we can do this, and we can just look for brokers that exist in the wild. And two questions come to mind, like which addresses should we scan? Where should we look for such brokers? And how do we know that we actually found a broker, right? How can we tell that? And the answers are quite straightforward. So we should scan the entire internet. There are like 4 billion addresses. That's not so much. At least in IPv4, it's not so much. And the success indication is also quite easy. I mean, it's the server can just reply with we can just ask the server, the broker, to send the packet back to us. And this is how we will know that actually the server is doing what we asked it to do. Okay, cool. So I wrote this basically probe module in a project called ZMAP. ZMAP is a very nice project for scanning the internet, if you want to scan for some vulnerabilities or stuff. And I wrote this probe module, and if you have a nice direct access to the internet, I mean, you shouldn't do it from a private network like here, but maybe from, Google virtual machine, like a GCP, Google Cloud Virtual Machine can work well, and you have a reasonable bandwidth, then you can just scan the internet in a few days. And yeah, so I first started with my first setup, and I have a very old router at home, or I used to have until 2 years ago, that was from 2010, and it runs OpenWRT. So I just compiled ZMAP with my custom module to this OpenWRT. My ISP was not complaining, it's very lax. I don't think anyone is monitoring IP layer. So I think the only monitoring there is on the internet is in the 4th layer, so TCP or UDP or SCTP. And when I was scanning the internet in this layer, in layer 4, I got many complaints, but if you're scanning the internet for layer 3, that's awesome. Nobody cares. Okay, so go ahead and do it. And yeah, But there is just one minor problem, that my girlfriend was pissed because I was choking the internet. And I cannot deprive her from Netflix for 5 days. So this didn't fly. So I came up with a better setup. And this was Google Cloud, right? Why is the title so small? Well, anyway, so Google Cloud, basically you do get an IP address, but you get an internal IP address, and there is a small problem with that. Zebop doesn't really like to scan from internal addresses because you're trying to do when you're trying to reach external addresses. So it's a small complication. I won't go much into details, but the thing is you can bypass this complication by spoofing your own external address. So I think what happens, I didn't verify it, but you have two parts there. You have the network address translation that translates your internal IP address that you get in the Google network or in your private virtual network within Google Cloud. And then there is the external IP address, your ephemeral address. And there is the address translator that translates from the internal address to the external address. And after that, I think there is the firewall that actually drops packets if you're trying to spoof packets. And if you're spoofing your own external address, there is no problem, because the first part, the address translator, will not translate anything, because the source IP is an external IP. And the second part, the firewall, will not drop the packet, because it originates from your own IP address, which you're allowed to send packets from. So that's cool. And basically, I started scanning the internet, and I failed completely, because, I just didn't get any results. And that sucked. But I asked a friend, I asked POCGTFO, the guys there, if they want me to write a paper about failed attempts. And they said, yeah, sure, just make sure everything works as you want, and, just do the paper properly. And I said, yeah, sure. So I asked a friend to go over it, and he said, have you ever tried to set up a real target that is actually vulnerable and see if you find it? And I said, well, no, I'm a hacker, I'm not doing tests. And he said, well, you should doing tests. So he put up this kind of server, and lo and behold, I didn't find it because I had a horrible bug. So I sat there, I fixed the bug with the help of this friend, and then I got tons of results. Okay, so maybe another lesson is just, even if you're a hacker and you think highly of your code, don't. I'm a terrible code writer, so you should always test your code. And before we talk about the findings, let's do a short demo, and I'll show you how this looks like. So, pray to the demo god, and okay, we have this, okay. This is this would be my victim. This is my my VM in Google Cloud, and you can see this is its address. And now let's do some TCP dump, and we're listening on port 5353. And here we're gonna send a normal packet, no spoofing, nothing complicated, just a normal packet. Okay, so don't look at my code, great, at my password. And we're sending this packet, and you can see this packet has arrived safely. That's great. Now let's do some IP spoofing. Okay, so you don't see, but I'm going to send a spoofed packet, and you can see that I stacked. Wait, this is not spoofing. Where is spoofing? Sorry. I'm sorry for that. So let's say that I'm spoofing. Oh wait, it is spoofing. What am I doing? Sorry, it is spoofing. You see the source address is 1234, right? So I'm just trying to spoof source address 1234, which is not my address. Let's send it, and you see that nothing happened as expected because Google just dropped it. Okay, now we're gonna do something nice. We're going to scan the internet from this machine. Okay, so I'm running my own custom ZMap, and all these parameters are tuning to make the scan go fast on this specific machine. You can see that it is running, and if we're checking the results, you can see it's actually finding some IPs. Great. So now let's take all these IPs. Alright. And let's put them in this script. That is actually... Okay. What this script does is that it's going to use every one of the IPs we just found in the search and ask them to do and send them an IP packet that is the spoof packet over IP. Okay, so let's do it. And, well, we're kind of lucky because, as you can see, the 1234 is the source address, which is not our source address. So that was the demo. And it works. Even in, by the way, this is, yeah, sorry. Yeah, so this was in the, oh, great. This was in the conference network, so, yeah. It works from here. You can do it from here. Okay, so findings. So there were about 150,000 hosts that support this protocol. That's nice. That's a lot. I don't think any of them will shut down soon. And most of them can do IP spoofing, as I just showed. So not all of them are vulnerable to IP spoofing. Some of them has filtering, but some of them don't. And I don't really know why. And I can only guess, but my guess is that most of them are kind of deep internet devices that don't have firewall. They're just passing packets around from here to there, and they don't have, or they're their own ISP, or they don't have an ISP. But probably people that understand internet better than I am can tell you a bit more about it. Another cool thing we can do, except IP spoofing, which is cool on its own, is spoof private networks. So some of the ranges of addresses of IP are reserved for private networks. So within your Wi-Fi or cafe or something, you'll get addresses that are 192 or 172 or something like this. They are private networks, and maybe you and I will have the same private address on our private networks, and we cannot reach each other over the internet, because the internet should not forward packets that have their source IP being a private address and not internet address. Okay, these packets are called Martian packets because they should not travel the internet. I don't know who came up with the name Martian, but with some of these vulnerable machines, they actually forward internal IP addresses or private IP addresses. I even saw some of them forwarding the 127. So this is localhost, so you can actually spoof localhost. Yeah, that's cool, right? I agree. I couldn't get the packet back to me because my ISP was actually filtering Martian packets, but what I did, I was forwarding a packet from a vulnerable IP over IP to a vulnerable machine back to me, and the link in between had a spoofed Martian packet. So this is how I knew they're actually forwarding this stuff. This is the code you can see on your right. Another thing is that sometimes people actually trust their internal, like the private addresses. They don't trust the internet, but 127 is your localhost, so usually you don't authenticate localhost. So there are some attacks that you can actually carry out if you can spoof internal IP addresses, so that's cool. Last thing that was quite cool is that I accidentally found a packet of death. So what happened is that I reported a vulnerability to Cisco. They said they don't know of any open IP over IP devices that they have. And I said, okay. And then I was talking again to the guys at POC GTFO and told them, hey, I would like to submit a paper. This time a paper that actually does something that works. And as the name implies, POC GTFO requires a POC. So I thought, what would be the coolest POC that I can come up with? And I thought, well, I can do IP over IP. Why not over IP and do it recursively? And in this way, I can actually travel the internet more than 255 times, which is for a normal packet. Yeah, for a normal packet, this is the maximum time to live, right? If a packet travels the internet more than 255 hops, it should be dropped. But if you're having an IP over IP, every layer has its own time to live. So I actually built this more than 350 layers of Pass the Parcel game of the internet, and it's cool, and you can do it too. If you want, I'll give you the code that does it. It's a bit, it's not polished, so I didn't feel right to publish it, but if you want, I'll just send it to you, just mail me. And then I got this nice email from the guys at Cisco saying, we do actually have a vulnerability, and it's not the IP thing, is that you're crashing our devices. So please stop doing your tests or something. Yeah, I said I'm sorry, and I stopped, but it was quite funny. So that were the findings, and now we're gonna talk about the disclosure. This is the part you all came here for, right? Yeah, great. Okay, so disclosure of this kind of vulnerability, or misconfiguration, I don't know how you would call it, but it's kind of a hell. Because all you have to go by is the IP address. And as we know, IP address does not mean you know who the owner is or what the device or operating system is, right? It can be in the DMZ, it can be something that only forwards packets to somewhere, and if you're trying to fingerprint it, you're actually fingerprint the machine behind it to which it forwards packets, but the IP over IP happens in layer 3, it happens in the kernel, so you don't really know what you're fingerprinting exactly. There was one fax, I didn't put it up just for the joke. There is some Samsung printer that was later bought by HP, and some university connected it to the internet, and it was actually vulnerable to this, so it exists. And also scanning the entire internet takes time, and it's expensive and whatever, so this two guys really helped me. Larry Cashdollar, that was working in Akamai security, I reached out and asked for help for someone that, some of the internet stakeholders, so Akamai is an internet stakeholder, I think, and they helped me to scan the entire internet. So the list of 150,000 IP addresses came from Akamai, and they also got me in contact with CertCC. So this guy, Vijay from CertCC, helped me to disclose the vulnerabilities to various companies. And let's talk about how that went. So I started with Digi, because they're the biggest, they have the biggest share of vulnerable machines that I found and could identify. They, I think, had 10,000 or so machines. They're doing some kind of cellular ISP or something like that. Maybe it's not 10,000, maybe it's 1,000. I don't know. I'm messing up the numbers, but they had the biggest share. Okay, and they were very professional in letting me test the vulnerability on a default configuration and talk to me. But they didn't tell me how the vulnerability came to be. I mean, I guess they ripped off some open source code from somewhere, but they didn't tell me from where. Maybe some BSD or something. And they promised a bounty, but they had run into some legalese issues, and I never heard from them again. And they were the best, by the way. So next came up Cisco. So I already told you what went down with them. So first they denied they have vulnerability. Of course, they don't have vulnerability. Okay, great. I mean, I only have an IP, so I can't be really sure it's a Cisco device, right? So I said, okay, whatever. And then when their machine started crashing, they came back and say, we do have a vulnerability, that's cool, and then I found out that Cisco does not have a bounty program at all. So that was weird, and I'm not going to make assumptions about Cisco's code quality, given this lack of bounty program, but that was it. HP were the worst. They failed to communicate over PGP. They asked me to... they told me that I should ask them for the private PGP key over mail, which kind of defeats the purpose. Exactly my response. Exactly. Thank you very much. And also they don't have, I think, a bounty program, so that was HP. If there is anyone from HP here in the crowd, I'm sorry, but you should get it work. I want to say something. I think the security teams in all these companies are really good and professional, and I think it's a management problem. So if there is someone from the management that can actually fix that, I mean, they should. But I'm preaching the choir, right? Okay. So last thing was HackerOne. They're actually running bounty programs. I thought that would go much better, right? And they do have a bounty program called the Internet Bounty Program. And this program was designed for this kind of bugs that affect the entire internet as a whole. And I think it kind of applies in my case. So I sent them a report after submitting and disclosing and everything. And for a year, nobody read my report. So this didn't work at all. And after a year, they shut down the program. They gave me a few $100s, which was the lowest amount they would pay for a valid submission. And that was about it. So my sad conclusion from the disclosure process is that it sucks. I mean, if you want to disclose vulnerabilities because you're a good guy or because you want to talk about it afterwards like I do now or whatever, that's cool. But if you're expecting some bounty or any recognition of any sort, well, good luck with that. Don't base your income on bounties. That's a bad idea. Okay. So the last part, what the future holds. So, I said that I was doing it in my free time, and you can do too. I would be happy to share other stuff with you. And the things I would like to do or see other people do with this research is actually set up a full TCP connection into an internal network. So the thing is that I don't know exactly what are these vulnerable machines are. It's really hard to fingerprint them. So if you do know, and you know there is an internal network behind them, maybe you can try and do some full TCP handshake, like kind of blind TCP handshake, because you're not getting the responses, right? But if you can make that happen and actually connect to internal services, that would be awesome, like an awesome POC. And this entire thing, this IP spoofing is a stepping stone, right? It's not the goal in itself. It's something that gives you capabilities that would eventually lead you to a successful attack. So on its own, it's not really helpful. And actually succeeding in setting up a full TCP connection would be another step in the way. The next thing that could be really nice is actually use the Martian packet spoofing to do some stuff, like with the localhost spoofing. That could be really nice. I think the last one that was doing it was a guy, Stefan Woodger, that published a blog post in Project Zero, and he was spoofing IPv6 localhosts back in 2015, and he owned NTPD. So, and ever since I didn't see anyone that was doing it. So now it's possible again, maybe not on your local network, but maybe on the internet. So if you can find some service that is vulnerable to this kind of thing, that would be cool. Scanning more protocols, that can also work very well. I started playing with Jerry. There are very promising results over there, and it's not too hard to write a ZMAP module for it. So it remains as an exercise to the audience. And yeah, you can also try to do the 6/4 and 4/6. 6/4 could be easy because you can actually scan the entire IPv4 range. Again, 4/6 can be tricky because scanning the entire IPv6 address range can be a bit too much. But if you know how to do it, that could be very cool. And the last thing is that I never got a hold of a Cisco device that was vulnerable to this packet of death, but basically it's a packet that crashes the kernel from the internet without authentication. So if you do have this kind of device and you want to play with it, and maybe find an RCE into the kernel unauthenticated, that would be really, really awesome. But I couldn't get my hands on any of these devices, so that's left to everyone who wants to try. So that's everything I have. If you have any questions, I'm here now and also in the conference. And if you want to follow me, get the ZMAP module and all that, so this is what the thing. And if you want to see more memes like this, you should check out this exploitation Twitter. So yeah, thank you very much. Yes? No. I could have used. I did try 8888, and it works if you're not spoofing into Google Cloud. Because this is what I did yesterday when I recorded the demo to make sure it works, and it didn't work for an hour, and I didn't understand why. And then I realized I'm trying to spoof 8888, which is a Google address, inside Google Cloud, and they dropped it. But I didn't try the example IPs. But I did try 100, for example, that Tailscale is using. And if you read Tailscale documentation, they will tell you that if you're listening to the Tailscale interface, you should trust incoming packets source IP because they're validating them. But the fine print is that you should only trust it if it comes from the Tailscale interface. If you're binding to the entire machine, then you may get packets not from the Tailscale network. So this stuff can actually do damage. Yeah. Yes.
I'm assuming you can't spoof IPs from the ASM you are trying to spoof into because it knows that the source IP is inside.
Yeah.
But the packets came from the outside.
That's what happens with Google. Yeah, exactly. There's also egress filtering, which is the opposite. That ISPs and cloud providers should not accept packets that should have originated from the internal network if it comes from the external network. As well, they should also not accept Martian packets, but not all providers implement this.
Does it also include like the nearest BGP networks that it is connected to or not? Do you know that?
I didn't check, but go ahead and let me know.
Okay.
Anyone else? Yeah. No, I never managed to do it. I only found those on the internet, and they worked. The way I did the testing, I wrote it in basically Scapy. I wrote a Scapy server that would accept any packet, decapsulate it, and send it back. But I could not do it, the way you should be doing it with some, IP routing stuff of the Linux machine. It's just impossible. I don't know how you guys do it. I mean, not you guys, but they guys. Yeah. Yes, again.
I can also give a hint. If
Yes.
you're trying to report a vulnerability like that, and you don't know, you only have an IP address, you can geo-IP it into a country and send it to a national cert in the country and hope for the best. It doesn't work usually,
Nope.
but it's better than nothing.
Yeah, I tried it with some Chinese vendors and I didn't get a response, so... Yeah. Okay. Yeah, I think that's about it. I'm still here for questions afterwards if you want me. Thank you.